Hi, everybody. This is part 2 of the topic that we started discussing in our last lesson. Do you remember that the goal that we're working towards is solving equations involving complex numbers? Here's one example. In order to do that, we need to use the steps of arithmetic, and in the last lesson, we talked about addition, subtraction, and multiplication. There's one operation left to discuss, and that's division. So that's what we're going to do right now. Dividing complex numbers, actually very different from dividing real numbers. We're going to need to use the complex conjugate to do so. I want to take a look at an example. So I have two complex numbers that I'm dividing here. I set that up. And one of the things that's guiding my work is the fact that I need to report my answer in standard form a plus bi. Well, I took the fraction that I have here and I separated it the way you see in the slide. Okay, so notice that I took the top, the numerator, and I broke it up into its real part and its imaginary part. But unfortunately, I am not done. This is not in standard form. And the reason this doesn't work is because of what's going on in the bottom of those fractions. If I'm dividing by I or dividing by a number that contains I, well, then what I have is not purely real. And so the last line here is not in standard form. We're going to have to take another approach to this problem, and what we're going to do involves the complex conjugate. The rule for this problem is we're going to multiply top and bottom of our fraction by the conjugate of the denominator, the conjugate of the bottom. So in the division problem that we're working on here, I'm going to look at the denominator, that's 5 minus 7i, and then I'm going to multiply both parts of my fraction by 5 plus 7i. That's the conjugate. Look at how I change the sign on the imaginary part only. So next I set up the multiplication that I'm talking about. You can see that I multiplied top and bottom by 5 plus 7i. That's the conjugate of 5 minus 7i. The first thing I want to ask, is it actually okay that I do this multiplication? Well, notice that the fraction that I have on this second line, top and bottom are the same, so that fraction simplifies down to 1. When I multiply by 1, I don't change the value of what I have. So I'm not changing the value of z over w. I'm just changing the way that it's written, and I'm going to be able to write it in a form that's more convenient for us. All right, so yes, setting up this multiplication, that is legitimate. The next thing I did, I carried out the multiplication of my two fractions, and then I simplified everything down. What I did on this step, that's what we talked about in our last lesson, multiplication of complex numbers. And notice what happened in the denominator. Whenever you multiply a number and its conjugate, the result is always purely real. This is the reason that I set the problem up the way that I did. Once I have a purely real denominator, I'm going to be able to break the top of the fraction up into two parts. Okay, I did that here. And then it turns out each of those parts actually can be simplified. There's some common factors in the top and bottom. Okay, so after dealing with all of the fractions, I get this as my final answer. And notice that what we have here is in standard form. We have a plus bi, and the numbers a and b are strictly real numbers. I'm no longer dividing by anything complex. Everything in those fractions is purely real. So this is the final answer to our division problem. And this is the reason that you have to use that step involving multiplication by the conjugate. Okay, I want to take a look at one more problem. Here's another division problem, 1 divided by I. There's a couple ways that we could look at this. So first, I could do exactly what I did on the last example. Set it up as a fraction, multiply top and bottom by the conjugate of the denominator, so on. But I actually want to look at the second method in a little bit more detail. This related to powers. Remember that 1 divided by I can also be written as I to the minus 1 power. This was another problem from our last lesson, integer powers of I. The idea that we use to simplify this is related to multiples of 4. So here is what I want. The multiple of 4 that I'm looking for is actually negative 4. And then I have plus 3. Use the rules of exponents to split that up. And then we know that anytime we have an integer multiple of 4 up in the power, that just is 1. Leaving me with I cubed, and the last step, that's equal to minus I. So I wanted to do it this way, do this problem using this method to remind you about integer powers of I, something that we talked about last time. So what we have done now, we've talked about all 4 of our basic arithmetic operations. Now we have all the tools that we need to solve a simple equation with complex coefficients. I have an example of a problem like that here. I want to take a look at the steps to solve it. Very similar to what you would do in basic algebra. We're going to use our basic operations from arithmetic, and we're always going to do the same thing on both sides of the equation. The goal that we're working towards is to get z, the unknown, by itself on one side. In the problem that I have here, the first thing I'm going to do is subtract. I'm subtracting 1 plus I from both sides. This is a problem we looked at in the last lesson. Matter of combining like terms, and you can see the way that simplifies down on that last line. In order to get z by itself, there's just one more step I have to do, and that's division. So I'm going to divide both sides of my problem by the coefficient of z. I set that up here. Now I have my final answer z in terms of a ratio of complex numbers. The last thing that I'm going to do is complex division. This is exactly like the example we looked at a couple minutes ago. So I'm going to think about multiplying top and bottom by the complex conjugate of the denominator, and then simplifying everything. I laid out all of the steps here. These are things we've already talked about. And so the final solution to my equation, that's what you see on the last line. 12 fifths minus 1/5 I. What we just did, we talked about solving an equation, and this would be an example of a linear equation. The reason it's classified as linear is that our variable z only occurs to the first power. The next thing we're going to talk about is quadratic equations. So there we have our variable squared. And in order to come up with the answer to this, we're going to need to take the square root of a complex number. This is a problem. We're going to look at this problem in a couple different ways. Now, on the homework, I have kind of the first approach to finding these square roots. So that's something I'm going to ask you to look at. And then also on the homework, here's sort of a summary of what we've done over the last 2 lessons. So I'm going to ask you to do all of the basic arithmetic operations with these complex numbers. We had a special case, integer powers of I. That's something that you need to work with. And then finally, the problem that we just looked at, solving a linear equation with complex coefficients. All right, that's all for this lesson.